When adding vectors together, we're going to use the tip to tail method. And honestly, it doesn't matter what order we add them in. For this exercise, we'll add them in the order presented. So let's look at the first one. A vector pointed to the right, 5 units long, is added to a vector pointed straight up, 10 units long. So imagine you walk 5 meters to the right, and then you change direction and you walk 10 meters, say, north. So 5 meters east, 10 meters north, what's my final displacement overall? Now, these could be any vectors. I'm just giving you an example to put some context behind it. So the way you do these is you add them together tip to tail. Try and keep your scaling so that when you come up with your final solution, when you do it mathematically, it makes sense. So when I walk 5 meters, there's my first vector. And now I start at the tip of this vector with my next one. And the next vector is 10 meters north, so it should be twice as long, upwards like that. Now my answer always points from start to finish. So my answer will point from here, where I started, to the tip of the last vector, where I finished, and it will look like that. And I always put 2 arrowheads on my answer. So 5 plus 10 will give me this red vector. And you can imagine how we would solve that. You'd simply use Pythagoras since we've got a 90-degree angle there. You could even get the angle using the trig functions. But that's another lesson. Let's look at the next one. Notice it's the reverse of the first one. So it should give me the same answer. Now, if I drew this exactly to scale with a ruler, it would give me the precise answer. But let's see if we can get close. So now I'm starting with 10 units north. And then at the tip of this one, I start my next vector. 5 units to the east. Now, I'll use red. Here is where I started my diagram. This is where I finished it. So my final answer points from start to finish. And this red vector, if I did it correctly, will be equivalent to the previous one. It'll be the same magnitude or the same length and same direction, so they should be parallel. All right, let's look at the next one. Grab my yellow pen. The next vector takes 10 units north and adds it to 10 meters to the west, which they've identified as -10. Doesn't matter, we've got the directions. So I'll do this one a little bit over here so I have enough room. So my first vector is 10 units north. And then at the tip of this one, I start my next one, which is 10 units to the west. And again, my final answer, which I'll do in red, it points from start to finish. It'll be this vector right in here. Sorry about the crooked line. There we go. So if we ignore that crooked line, you get the idea. Let's look at the last one. 5 down, or 5 units south, added to 5 units to the right, or 5 units east. Also, we're going to add 10 units to the north. Now again, it doesn't make any difference what we do when we add them in terms of the order. So let's add them in the order presented. And then maybe for kicks, if we have room, we'll do it in the other order as well. So 5 down, another 5 to the east, and then 10, which is twice as long, up. 10, 5, and 5. Now my final answer is from where I started the diagram and points directly towards where I ended the diagram. So from here to here. Your answer always has to have an arrowhead on it. So there's my final answer. Let's try this one more time by doing it in reverse and see what we get. Again, we can do it in any order. So if I start with the 10, and then I add, there's 10, then I add 5 from the tip of this one to the right. So I've done these two. Then I add another 5 that's down. My final answer points from start to finish. There's the start, There's the finish. So my final answer is like that. And again, that vector should be the same length and same direction as my original. So it doesn't matter what order we do them in.